Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 Past Paper, June 2014. We're looking at question 8 here, an old vectors question from the FP3 syllabus. Right, okay, so here we're looking at, we've got a line, L passes through this coordinate here and is perpendicular to the plane pi, whose vector equation is this. Right, okay, so let's draw out some more detail about what pi is. So pi is a plane, and what we have it in is this form here, r dot 1 minus 2 minus 1 equals 3. So what that 1 minus 2 minus 1 refers to is this vector here, the n vector, which is 1 minus 2 minus 1. And all planes can be defined by that perpendicular vector. And 3 here refers to some proportion of its distance to the origin. So let's look at part A. All we know about the line is that it passes through here. Find the vector equation of L. Okay, so it passes through here. So I know that my vector can start at 2, 1, 3. And if I'm also told that it's perpendicular to the plane pi, well, this vector here is perpendicular to the plane pi, so I should be able to get from this vector here to the vector that the L moves along, and in fact it is exactly this same vector. It's plus lambda 1 minus 2 minus 1. The reason that it is exactly this vector here is because we're told that it is perpendicular to the plane pi. This vector here is perpendicular to the plane pi, so they must therefore be the same perpendicular. Part B, find the position vector of the point where L meets pi. Okay, so pi, let's write pi out. That's r dot 1 minus 2 minus 1 equals 3, and I also have an expression for r here. That's 2 plus lambda 1 minus 2 lambda and 3 minus lambda. So what I'm going to do here is I'm going to plug this equation for my line into the r value in my plane. So therefore I can then go ahead and work out what lambda is, and then I'll be able to get to my points from there by plugging lambda back in. So 2 plus lambda 1 minus 2 lambda 3 minus lambda dotted with 1 minus 2 minus 1 equals 3. So now we need to do the dot products. Remember, that's top times top, middle times middle, bottom times bottom, and add them together. So it's going to be 2 plus lambda, and then minus 2 plus 4 pi, and then minus 3 plus lambda equals 3. So this is going to equal 6 lambda equals 9. Those two cancel. So lambda, so 6 lambda equals 9. No, 6, sorry. So lambda here equals 1. So therefore I can now go ahead and work out the position vector where L meets pi by plugging lambda back into here. So the position vector is going to be 2 plus 1 is 3. 1 minus 2 times 1 is minus 1, and 3 take away 1 is 2. Great. So all that's left for me to do is now answer part C. Part C looks for me to find the perpendicular distance from P to the plane pi. So let's say we have the point P up here. The perpendicular distance down to our position down here, our new position, is just going to be the magnitude of the distance. So P, let's call this position coordinate x, So we do x take away p. The reason we can just do this straight away and we don't have to go through the whole formula of coordinate to the plane is we already know that this distance is perpendicular. So that helps us. So it is literally just this distance from this coordinate to this coordinate. So that is 213, no, other way around, 3 minus 1, 2, take away 2, 1, 3, 1 minus 2 minus 1, and all that's left for me to do now is to find the modulus. 1 squared add 2 squared add 1 squared. 2 squared is 4, 5, 6, so it's the square root of 6. So that's your answer to part C. 8 marks in total for that question.